Welcome back to the MOVI-C Control Cabinet Products Basic to Intermediate Training. This is session 5. The end of the introductory material is in sight and we will be spinning the motor pretty soon. Just hang in there. In this session, we're going to learn about the many different connectors available on the control cabinet products. We're going to look at the VFDs, we're going to look at the controllers, and just kind of do a quick summary of all the connections. We'll talk about the internal software, that's the firmware, and the application programs called MOVI kits. We'll give you just a brief overview of those. And finally, we'll wrap up by talking about how you connect your PC to the different products so you can start working with it using the software MOVI Suite. So without further ado, let's jump in. Let's talk about the connectors. The connectors on our products are relatively consistent, but there are many of them, and you need to know where they go. Of course, the manuals cover this, but I want to just summarize it quickly. Let's look at MOVI Drive Technology and MOVI Drive System. They have more or less the same connectors. They're very similar products. So let's start with the front. On a MOVI Drive Technology, there is a 9-pin D-shaped connector. You can either plug a keypad into that, or you can connect an engineering cable that goes to a PC. And this is how you could engineer the device if you want to set it up using our MOVI Suite software. On the MOVI Drive System, you cannot connect a keypad. They don't accept the keypads. But they do have an engineering interface, although you notice it's a different style. It looks like what you used to use to plug in a landline phone. It's an RJ style connector, a little one. So you would use a different cable, but you could plug into this and you could connect it to your PC through a USB adapter, and that allows you to connect in with MOVI Suite and engineer the device. MOVI Drive Technology has a field bus card, so there will be field bus connectors there. MOVI Drive System does not. Notice there's a knockout panel there instead, because remember, you don't access those on a field bus directly. You connect through the field bus on the controller. Then you have I/O connectors, and we do include those connectors with the screw terminals. So this is how you hook up the digital inputs and the outputs. MOVI Drive Technology has 2 extra inputs, and it also has a relay connector. Notice there's a connector down there. If you look at the system, there's just knockouts there. Those are blind connections there. So there is a difference, and you cannot connect up a relay on a system. Those black covers, by the way, are the expansion slots where you can put in cards. They come in 2 different sizes. Some cards are bigger than others. So 2 expansion slots. Now, the top and bottom are identical on MOVI Drive Technology and Systems, so let's kind of do a quick tour of the connections. First of all, we have a connection for the motor and a brake resistor. So this is where you would make the connections to the motor and the brake resistor at the bottom. There's also a connection if you have an electrically controlled brake on the motor, you can control it. There's a connector there that plugs into it. If the motor has temperature sensors for thermal monitoring, you can connect them there, and the VFD can monitor them and make decisions based on how hot the motor is. So those connections are there. There's the connection for the multi-type encoder. Plug it in there, and the DDI connector, if you're using a DDI motor, that digital motor interface, there's the connection for the little teeny coaxial cable right next to it. On top is line in. This is where you would connect up the 3 phases to the power supply and also, of course, the ground connection. This is where you put in 24 volts to provide the energy for the electronics. Here is the S-Bus Plus EtherCAT interface that you would use under certain conditions. And here's the safe torque off connection. Right now you can see there is a jumper there that disables it, but if you have a safe torque off circuit, then remove the jumper, replace it with connections. So those are all the connectors on a MOVI Drive Technology and a MOVI Drive System. Let's move on to MOVI Drive Modular. Where are the connections there? All right, here's the power supply module. It has 24 volt connections there if you need to supply it with 24 volts. There's also a protective earth, in other words, a ground connector for that high voltage DC link. And there are two connectors there for the high voltage DC link bus bars. Those bars carry almost 700 volts. Be very, very careful around these connections. They're normally covered with a protective cover. This is where the brake resistor goes that takes the regenerative energy from all the access modules. So connect your brake resistor here on the bottom. There's another protective earth connection there. And this is where you bring the line in. So this is typically where the 460, 480 would come in. On the top, you have a connection that can monitor the brake resistor's thermal sensor if it's got one. If it doesn't, you can put a jumper in its place, as you see here, so it won't trigger. But remember, it is possible to watch the brake resistor to make sure it's not getting too hot. And there's the S-Bus Plus connectors, because even the power supplies are connected up to that EtherCAT system so they can be monitored. Access modules. On a MOVI-Drive modular, you will have access modules, either single, double, or a mixture of them. Remember, in general, a double access module is just a duplicated single access module. There are some exceptions, but pretty much they're the same. You will have the I/O connection or connections, depending on whether you have single or double. There will be either one or two expansion slots. There will be the encoder interface or interfaces. And underneath, there will be connections for the brake, if the motor has a brake, and the motor thermal monitoring, if there are temperature sensors in the motor. There's also the DDI connector. Single access module will always have one. Double access modules will have two, but only if they don't have the encoder interface. You will not see two encoder interfaces and two DDI connections. You'll see either two of one or two of the other. And then finally, this is where the motor and its protective ground wires go. On top, you will have the safe torque off connection or a jumper. And you will have the S-Bus Plus EtherCAT connectors so they can talk to the controller. What about the controllers? Well, the controllers are connector city. There are a lot of connectors on our controllers, and I'm just going to skim through them quickly. I urge you to look at the manual of the specific controller that you have. This is our lowest end controller. It's controller standard. It's got an engineering Ethernet connection. This is for engineering the drive and all that's connected to it. There's also a pair of field bus connections. There's a 24-volt connection on top for its electronics. There is a single EtherCAT S-Bus Plus interface. The reason there's only one is because the controller is the master, so it's kind of the beginning of the chain. There's also a connector that supports what's called CAN. CAN is an industrial network used in certain things. As far as I know, we really don't do anything with this at this time, but we do have it in here. I'm not sure why, but it is there, so that's just what the connector is. Controller Advanced is similar. It's the next step up the chain of controllers. It has two engineering ports. They do the same thing. You can connect to either one of them. It's just two different positions, one on top and one on the front. There is a pair of field bus connections right there. 24-volt connection for power. There's the S-Bus Plus or EtherCAT connection. Again, it's the beginning of the chain of devices. And there is an RS-485 and a CAN interface. I do not believe we currently have any applications that use them, but the hardware is there. Moving up now to the controller Progressive, which is the one that can run Windows as well as SEW firmware. It has three engineering ports on it. Two are for the SEW side and one is for the Windows side. Remember, I said they had separate engineering ports. These are all Ethernet connections. You would connect them to a PC and engineer the side you care about. There are two CFast slots. One holds the SEW firmware, and if you buy a Windows license, the other holds Windows. There is a 24-volt connector for power. The S-Bus Plus connector to control the chain of devices. There is an optional slot to put a field bus in there if you wish one, And there's also a display connector to go to like a touch screen or a flat panel display. There are some USB interfaces on there, by the way, you may have noticed them, so you could connect up a keyboard or some kind of pointing device too if you wish. And then lastly, this is our biggest controller at present. This is controller power. It's got similar connections to it. It's got 2 engineering ports. It's got 2 CFast slots as well. It's got a 24-volt connection. It's got the S-Bus Plus EtherCAT port to connect to the chain. It's got a slot for a field bus card. We have several choices available. And it's got a DVI type display port to go to a display or a touch screen. And you can see there's some USB ports and actually a RS-232 COM type port as well. So many connectors, many choices. And do remember the Windows part is optional and it comes on that second card if you want it. Okay, I'm sure you're tired of connectors. Let's move on. Let's talk about how you know what's going on the VFD. How do you get its status? How do you know if there's something faulted? Well, the answer is you look on the displays on the front of just about every single piece. Almost every unit or module has a 2-digit, 7-segment red LED display, and that provides status and diagnostic information. So you can see here we have a MOVI drive modular, and it's also got a MOVI drive system bolted right next to it. And everything but the controller, even the power supply, has a status display on it. And those numbers and letters tell you what's going on. For example, if you see a C2 on one of those, it means safe torque off has been triggered and the motor is immobilized. It won't turn and develop torque. So the power supply's got a status. The MOVI drive system has one, and the access modules have individual status displays. And if you've got a double access module, which I don't have here, it has 2 displays. So you'll see one for each axis. Let me show you some of the common status displays that you will see on axis displays. These are not errors. These just tell you what the axis is doing at the moment. For example, if it's running in speed control mode, you'll see 0.5. And that just means it's running and it's operating at a specific speed. On the other hand, if you see a 2.0, that means it's in jog mode. It's jogging. If you see 0.2, it means it's come to a default stop. So these are status displays. This information is extremely useful, and you'll use it all the time when you're working out what's happening at a given moment. The power supply pretty much displays one of 2 messages, either an RD, which is good, it means everything's ready. If you see a 0.0, it means that the high voltage, the 460, 480, is not there. It's off, and there's only power for the electronics, the 24-volt supply. If you see that, you can talk to it, but nothing will happen. The motors don't have anything to run. Now, you will also see errors on some displays, and the way an error appears is a sequence of letters and numbers. You will see, for example, an E, a pause, then a number like 08 here, a pause, and another number. And what that is the complete error code. So in this case, 08 is the main error code, and 01 is the subcode, gives you more specific information. Now, how do you interpret this? There are several ways. Of course, some errors you'll get used to because they're common ones and you'll just know them. But what if it's a foreign one you've never seen before? There's several ways to do this. You can plug in and go into MOVI Suite, and you'll get a text message from that telling you what it is. If you have a keypad, it will give you a text message. And of course, ultimately, you can just head to the manuals, turn to the right pages, and every single possible error is documented and explained. All right, enough about faults and errors. Let's talk about what runs inside the VFD. Now, we've talked about the engineering software already, MOVI Suite. What we're talking about now is the firmware and pieces of software you load into the VFD or the controller to make it do its magic. Let's talk about those. Quick summary. SCW has introduced something with the MOVI-C generation called MOVI kits. I mentioned these very briefly in the intro. These are application modules that implement various kinds of control tasks that do not require you to do any programming. They're programs we've written for you. We've debugged them and made them really good, and you can just put them in, set a few parameters, make a few adjustments, and they will do sophisticated tasks for you. So this is really a great way to do powerful things without having to pay someone to be a programmer. MOVI kits are things that we make available. Some are free, some you have to pay for. I'll tell you more about that later. But they come in two basic categories. There are what are called drive level and controller level. What's the difference? Drive level MOVI kits run on MOVI Drive technology and to a limited degree on MOVI Drive System and MOVI Drive Modular. They load into the VFD itself, and they do a variety of tasks. Controller level MOVI kits work only on products with controllers, as the name kind of implies, and you can do more things with them. There are more controller level types because you've got that extra computing power. Some are extremely sophisticated. We even have a robotics controller level MOVI kit that allows you to implement a full robot. So there are all kinds of these. We will be digging into them in much greater depth later. I just wanted to hint at them now. It is also possible to write your own custom programs. If you are a PLC programmer and you know like ladder logic or structured text or one of the other 5 standard PLC languages, then you can write programs that run on the MOVI-C controller, the SCW controller, and those can run the VFD. So that is possible too. You don't have to do that, and if programming scares you, don't worry. We have lots of paths to avoid programming, but if you love to program, we have that capability. And eventually, I hope to be offering trainings that will help you learn to do that. We will discuss these topics in more detail later. Just one more topic, and we're going to wrap this up. Let's talk about how you communicate with the different VFDs, how you get MOVI Suite running on your PC to talk to the VFD that you're trying to deal with. You're trying to do diagnostics or engineering or commissioning. How do you connect to it? How do you communicate? Well, big idea here. There's more than one way to connect to a MOVI-C control cabinet product. We give you lots of doorways to get into the system to work with it. So if one doesn't work, then another is probably available. So it depends on the model you're communicating with, number one, and number two, what MOVI Suite, the software, can actually see depends how you connect. Sometimes you could see the whole system, sometimes only a piece of it. So let's go through the 3 branches. We'll talk about it, and that'll wrap things up for this module. MOVI Drive technology, that's what we're using in this class. Here's one way. If you've got a keypad attached to it, just plug a USB cable into the connector on the top. It's a mini USB connection on the top. Plug it into your PC, and magically that keypad will recognize the connection. It'll become an interface to allow you to engineer MOVI Drive technology. So this is a wonderful way to get in. If you just have that USB cable and the keypad's there, you're good to go. Another way to do this, and a lot of people do this if they do this professionally, they buy a product from SCW called the USM21A. It's a USB interface with a number of different cables that can connect to the engineering port on many of our products. If you do this for a living, rather than just occasionally, I recommend you get yourself a USM21A kit with all the different cables it comes with. And what you do is you plug one end into your PC through a USB port, the other you plug into that D-shaped connector, which is behind where the keypad is. That's called the engineering port. You plug in there and you're all set. You can connect in and engineer the drive. That is what we'll be using for this class. I will be using the USM21A. By the way, SCW sold something years ago that looks like this, except it's red instead of gray. It's called the USB 11A. You cannot use that with this product. It works with our older products just fine, but you need the gray one, the USM21A, for our current products. Another thing you could do is connect through the EtherCAT port on the top. You could connect your PC's Ethernet port, if you've got one, to the S-Bus Plus, the EtherCAT port, and you could connect in through there and engineer the drive. That is a third route. And the fourth is through the Fieldbus card. You could plug your PC's Ethernet port into the Fieldbus card and engineer it through there. So you can engineer and diagnose the drive through any of those 4 possible routes. Of course, in certain cases, they might not be appropriate, but one of these methods will get you in. So that's MOVI technology. What about MOVI system? Well, you engineer that typically through the controller's engineering port. You would plug an Ethernet cable in between that and your PC, and then you would scan in, and whatever's connected to the controller, you'll be able to see and work with. And if you have a whole chain of VFDs, you will see them all. If the controller can see them, you can see any one of them and work with a whole chain of devices, which is really neat. Alternatively, if you want to talk to a MOVI system, you take off the little protective cover, and there is that little tiny connector there, sort of like an old landline phone connector. If you've got a USM21A interface and the right cable that goes between it and this connector, you can talk to the MOVI system that way. Now, if it's in a chain of devices with multiple ones connected to a controller, you will only be able to see the one you're plugged into. You won't be able to see everything. But if this is the one you're trying to fix, that's great. That works too. And thirdly, you can connect through the EtherCAT S-Bus Plus port. But here's a gotcha. You'll have to disconnect it from the controller. The controller is an EtherCAT master, and when you connect your PC up, it's an EtherCAT master too, and you can't have 2 masters. They'll conflict with each other. So you'll have to break the chain with the controller if you want to do this. But if you're doing a standalone one that doesn't have a controller, this would work just fine. But just be aware that is one limitation. Finally, MOVI Modular. How do you get into this one to engineer and diagnose it? Pretty much the same way you do with MOVI system. The best approach is to go in through the controller's engineering port. And again, if you go in through there, you can see every single thing that controller can see. So in this case, notice it's got the power supply and 3-axis modules, and some of them are actually double-axis modules. You can see every one of those when you scan into the controller through its engineering port. So you can work with a whole chain of devices if you wish. Alternatively, every axis module has one of those little RJ connectors like a landline phone connection. If you've got a USM21A interface, you can connect through that port. However, if you do that, you will only be able to see that axis module. Nothing else will be visible, even though they're all connected through the EtherCAT network. So this is good for checking just a single axis module. And then your third choice is through the EtherCAT S-Bus Plus port, but again, you'll have to disconnect it from the controller. Otherwise, you'll have 2 masters fighting each other. So this is only good if you're willing to break the chain and go in and talk to just one module. So your first choice is usually your best. Go through the controller if at all feasible. All right, that was a big gulp. I gave you a lot of information. One more thing I'm going to say, and then I'll let you go, and you can take a big deep breath and go stretch your legs. Where do you go now? I've told you an awful lot about MOVI-C control cabinet products. What's the next thing to do? Documentation. We offer a lot of documentation on our website about our products, all in PDF format. I would suggest you start with this one, kind of the overview of the MOVI-C products. But every controller has a manual to it, so find the one that applies to your controller. Every VFD has a manual. Find the one that applies to your VFD or VFDs. Of course, a lot of the information overlaps because we have a very consistent product line, but all the specifics are in there. So I'm not telling you to go and stay up all night reading right now, but I am saying the documentation is there and you can use it and you can learn a lot. All right, well, that wraps up session 5. You've done a great job hanging in there, and I hope you've learned some things about the many different aspects of MOVI-C control cabinet products. We have just one more session before we're getting into our labs, session 6. In that session, we're going to take a quick tour of MOVI Suite, so you'll be prepared for the first lab where you connect to your demo unit and start working.